Hi. So what I want to do is tell you about different types of internal combustion engines. If you think of the word internal combustion, just means that we're burning some sort of fuel inside a contained system. So like a car engine, for example, is an internal combustion engine. In contrast, and this goes way back in the day, if you were to make a fire and then heat water over that until the water turned into steam, that's actually how old trains used to work, and that's called an external combustion engine. No one does that anymore unless you're into weird old trains and stuff. So internal combustion engines are what run pretty much everything today. Cars, trucks, small airplanes, mopeds, anything like that. Chainsaws as well, an important one. So there's a few different types of fuel and types of engine design. There's really three different ones, and we're going to look at them all in turn. So first we're going to look at gasoline engines, then we're going to look at diesel engines, and then we're going to come back and actually look at gasoline engines in more detail. We're first going to look at four-stroke engines and then two-stroke engines. So those three things, four-stroke gasoline engines, two-stroke gasoline engines, and diesel are the main types of technologies that are used in anything that you see on the road today. So let's go over to this amazing website. I'll put this on in the conference. What this is a really simplified version of how an internal combustion gasoline engine works. So let's slow this thing way down. This is a four-stroke engine, as you can see up at the top. Let's even slow this thing down more, and I'm going to identify different parts of this. This is the cylinder. The thing that's here in blue moving up and down is a piston. Down at the bottom, this is the crankshaft of the engine. And yeah, let's keep it like that for right now. So notice that the crankshaft at the bottom, there's some gears on it that are turning these orange gears. And see this little red rod? Whoop! There it goes up. It's coming back down. That in turn pushes this thing up at the very top. And what this is called a valve rocker, and it's going to open and close this valve. Whoop! There, the valve got pushed down, and then that made it open. There's the same deal over here. There's another set of push rods, another set of valve rockers, and a valve, and that controls this valve. So this valve's also opening and closing. So let's pause this thing for a second. What's happening is that the top of the cylinder is where combustion is actually happening. This is the internal combustion part of the engine. So you can see that there's one little inlet place here where we have air and gasoline coming in. And then what will happen is that just this thing on the bottom is constantly turning. And so it's going to push the piston back up towards the top. Let's step it forward a couple. So it starts to get pushed back up towards the top. Notice the valve closed. So now all the particles in there are getting compressed more and more. And you can see they're compressed even more and more. And eventually, right at the very top, this wire at the top goes to the battery here. And the battery basically sends current in there and sets off a little spark in this orange thing. This orange thing is called the spark plug. Boom, there goes the spark. So that sparks this mixture of air and gasoline here. And as that is sparked, it starts to explode. It explodes, and obviously it's going to create heat and energy, and so it rapidly fills the container, the cylinder, and pushes down the piston. So that piston is getting pushed down as hard as possible. That's what actually is turning the crankshaft down at the bottom, is the downward push by the hot expanding, well, it's no longer gasoline, the hot expanding combustion products of this gasoline explosion. So it gets pushed down. It's going to start to, they're showing it dissipating, meaning that it's losing heat. So it's done work by pushing this cylinder down, by pushing this piston down, and then also by turning this this rod here at the bottom. And by the way, the rod is what hooks up to the transmission of the engine and actually makes the car go forward. Okay, so now notice that we pushed the rod up so that the rocker arm got pushed down, the valve opened. So now what we're doing is getting rid of all the exhaust that we just created from that combustion reaction. Goes up to the top, the valve closes, and it comes down and we can refill it with new air and gas. This is called a four-stroke engine because there's four separate phases that happen in filling and then emptying this chamber at the top of the cylinder. There's the intake where you fill it up with air and gas. There's the compression phase, the explosion, or what's often called the power stroke, and then the exhaust stroke. So here's the compression phase, the power phase where we explode it. Here's the exhaust phase where we get rid of it, and then the intake phase where we fill it up with air and gas. Four different sort of cycles, pieces, and thus four different strokes. In contrast, and by the way, this is again gasoline, so this is mostly octane. In contrast, here's a diesel engine pumping along merrily. Okay, so notice a couple things first. All this crap down at the bottom is still here in the diesel engine. It's just been simplified. So the crankshaft that's cooked into the connecting rods and all this, push the rocker arms, the battery, all this is still here. They just simplified it so they're focusing just on the cylinders here. Okay, so let's slow this way down again. Let's let this run for a sec. I'm curious if you all can see how this is different. Okay, well, one thing that you may have noticed is that there actually isn't a spark plug here. There's this thing at the top, but there's never ever the moment where it actually electrically ignites. Instead, what this is, it's something called a glow plug, and it just glows hot, like a certain temperature. So here's, and I'll be impressed if people can tell this, but going back over to here, one other difference, it's almost impossible to see here, is that if you compare this volume to this volume, that ratio is something called the compression ratio. So in other words, it sort of makes sense. It's the ratio by which the fuel-air mixture is compressed. And in a diesel engine, again, it's hard to see here, that compression is way more. So in other words, we can squash the fuel in the air mixture much, much more than we can in a gas mixture. The more we compress or pressurize a gas, the higher its temperature. And thus, in a diesel engine, we're able to compress it so much that it actually gets hot enough that it spontaneously by itself combusts. So we don't need to have a spark plug at the top of this. And we can run it at higher temperatures and also at higher pressures. This glow plug is really only used when the engine's cold. And it's basically just to get it started, early in the morning. Otherwise, it's essentially working the same way. We still have an intake valve, an outtake, and an exhaust valve to bring in air and diesel fuel, and then after the power stroke, during the exhaust stroke, to get rid of it. It's still a four-stroke engine, even though no one calls it that because, well, people don't call it four-stroke engines, but it still has those same four cycles. Okay, that sort of should make sense about the main differences between diesel and gasoline. How does this play out in terms of their actual exhaust or pollution properties? A couple things. Oh, this is just the same. This is just a diagram comparing them. One thing is that because the diesel engine over here is operating at a much higher compression ratio, that means also that the temperature is much higher. So you might be able to imagine an impact that would have on the pollutants produced. Take a second and think. Because the temperature is much higher, it produces a lot more NOx pollution. Remember, higher temperatures, therefore the K value increases dramatically so that we're producing more NO, and thus more NO2. So diesel engines tend to be much higher in NO pollution. In addition, and this is a complicated thing, in addition, people, because they run at a higher temperature, there tends to be a higher ratio of air to fuel. So in other words, stoichiometrically, if we think of diesel reacting with oxygen gas that's just in the air, these things tend to be run so that there's more oxygen present and less diesel. That in turn means that this is sort of paradoxical, but it means that we create more particulate matter. You might expect there to be less particulate matter because particulate matter is sort of the incomplete result of combustion, but it turns out actually there's more particulate matter. This is the black crap that you see coming out of buses, from behind the buses. Until recently, in many diesel engines, there's also more SOx pollution. I don't know if you remember, but they've recently reformulated diesel to be ultra low sulfur diesel. So this is sort of less the case now. This is more, you know, what it used to be some amount of time ago. It's no longer such an issue. Okay, in contrast with gasoline, we have less NOx, less particulate matter, and less SOx, but gasoline itself as a molecule is much it tends to vaporize more easily, so we have more hydrocarbons. And remember, hydrocarbons are another big important molecule in the formation of smog. In addition, with gasoline, we also tend to make more carbon monoxide because they tend to be run at a richer mixture, meaning more gasoline compared to oxygen. So this sort of plays out if you actually look at the data for gasoline versus diesel engines. We're going to deal we'll deal with the CO2 thing last, but let's look at CO first. So again, this is average speed versus time. Gasoline, whoa, that's way more carbon monoxide emissions than the diesel emissions. It's pretty noticeable. Going down to the bottom, looking at SOx and NOx. Sorry, looking at hydrocarbons and NOx. Hydrocarbons, again, gasoline tends to be way more than diesel, again, for sort of the same reason that we were talking about. And then if you look at NOx, at least at lower speed, gasoline tends to be much higher. It sort of evens out in this region and then actually reverses so that gasoline is higher and NOx at higher speed. But for lower speed driving, which is the way most buses and many trucks are driven, diesel is much higher in NOx emissions. Something else about diesel that's important to notice. The trucks tend to be built in a much more sturdy way because they have to withstand a much higher compression ratio. So therefore, diesel trucks often last a lot longer. Because of that high compression ratio as well, diesel trucks, and you can sort of see this here, diesel is on the top here, they tend to be more efficient. So you get higher mileage than in a comparable gas vehicle. And again, that's because if you can compress the gas, the mixture of fuel and air into a smaller volume, then when you finally ignite it, you sort of get more work out of that highly compressed gas expanding rapidly as compared to a lower amount of compression initially. Okay, now on to talking about 2- and 4-stroke motors. Let's start by looking at a 2-stroke motor. This looks really different than our 4-stroke motor looked. Whoops. This looks really different than our 4-stroke motor looked over here. So let's slow this thing down and try to figure out again what's going on. This is our cylinder. It's a different shape. That's okay. This is our piston moving up and down in the cylinder. Notice there's this sort of weird thing on the top of it. Here's our spark plug. And then here's our intake valve over on the side. And here's our outtake area, outtake port or exhaust port. Notice there's not actually a valve for an exhaust port. That's significant. So now we're going to count what's going on. Okay, we're going to have to do this really fast because there's a lot of things happening. Starting to go up. So right now we're filling this bottom reservoir with fuel, and notice this intake valve is open. So it's getting filled with fuel and air. Okay, now the piston's moving down, the valve's shut, and notice when we get to here, there's a little area on the side where that fuel and air can start to go and fill in the top area of the cylinder. So we'll click ahead. So now it's completely filled in that top. As the piston moves back up, it cuts off that little bypass area. So now the top of the cylinder wall is sealed. Keep going. It's completely sealed, and so now we're starting to compress the fuel and air mixture, and bam! There's our spark. Again, spark, not just the actual compression and temperature increasing, causing the reaction to occur. A spark, so the reaction occurs. It starts off from there, it moves down, pushing the piston downward and then turning the crankshaft at the bottom. Okay, so now look at this, check this out. Here's how it exhausts. Instead of, again, an actual valve opening, it just goes out through the exhaust port. So there we have all of our exhaust starting to move out, and as you can see it coming out, you can also see new fuel and air mixture coming in. Now, you can imagine there's not an actual barrier here. So some of the fuel and air will stay in here after the cylinder moves back up, and some of the unburnt fuel will go out along with the exhaust. An obvious problem with this is that we're going to be creating pretty high amounts of hydrocarbons exhausting into the air because some of the unburnt fuel is going out along with the exhaust. So you can see, again, really some of the fuel mixture should be going out here as well. Another huge problem with this is that the bottom of this is all covered with oil because otherwise the crankshaft and the connecting rod would melt. Oil serves to lubricate and cool things. So when this, let's go back for a second. When this fuel and air is coming up here, there's also oil that's coming up into here. And that's why if you look at a two-stroke motor, it often has a sort of bluish smoke to it. So there's not a seal between the bottom and the top. In contrast, in our four-stroke motor, there's an actual seal, namely the sides of the cylinder, that never is breached. The side of the cylinder has something called rings on it, and those rings prevent the oil that's all down in the bottom of this thing from coming up into the top. There is no such seal in a two-stroke motor. So if we go to, if we go to YouTube and just type in two-stroke motor exhaust, we should see something that looks blue because we're actually going to be seeing that that oil from the bottom of the crankcase moving up into the top and combusting. So I don't know, let's see what happens here. Alright, so I pulled this up. I have really no idea where this is. In Karachi, there you go. Where the hell is Karachi? I should really know that. Interesting. The biggest city in Pakistan. My God, I'm ignorant. Okay, you don't need to be seeing this, but you all can look up where Karachi is as well. And as fringe benefit to this, though, you can see how lame the internet connection is at my house. My God, it's even lamer than me not knowing where Karachi is. All right, moving along. This is video footage of some two-stroke engines in downtown Karachi, and it's pretty good for showing just the level of pollution that exists from a two-stroke engine. Pay attention to the rickshaws in particular.
मोहलत खत्म हो चुकी, लेकिन इसके बावजूद शहर भर की सड़कों पर रवां दवा शोर मचाते और धुआं उगलते ये टू स्ट्रोक रिक्शे आलूदगी बढ़ाने का सबब बन रहे हैं.
Can you see the blue exhaust that is coming off there? That exhaust is coming about from oil that's combusting from the crankcase, moving its way up into the top part and getting combusted and then getting exhausted. So if you compare two-stroke engines versus four-stroke engines, here's four strokes versus two strokes. The two-stroke is much higher in VOCs or hydrocarbons because uncombusted fuel gets out there. It's also higher in particulate matter because it's a less efficient combustion process. And same deal is true for NOx. This is two-stroke versus four-stroke again. Sorry, I said that wrong. The opposite is true for NOx. Two-stroke engines operate at a lower temperature, thus they generate less NOx than four-stroke engines, even though there's way more hydrocarbons and more carbon monoxide in two-stroke versus four-stroke. So why use a four-stroke engine at all? Well, because basically, if you think about this process, there's more power strokes happening per rotation. So in other words, there's more power being delivered per time to the actual crankcase or to the crankshaft. So they end up being lighter and smaller, and thus they're used in smaller motors often. So chainsaws are usually two-stroke engines. Some mopeds, like hipsters like to use, are two-stroke engines. In contrast, things like trucks, cars are almost always four-stroke engines. So this hopefully gives you a little bit of insight into the difference between a couple of these, or into three of these different types of engine technology.